Okay, welcome back to the fourth clip on chapter 13. In the previously we were looking at the computing the expected return for a portfolio. Now this expected return for a portfolio we compute by using the weight for that particular portfolio weight for the particular asset multiplied by the expected return for the particular asset. And we do that for all the assets. So this is the weight for stock C multiplied by the expected return for stock C, which is here. Then this is the weight for stock KO multiplied by the expected return for stock KO, which is here. The weight is given in the previous slide. We computed this in the previous slide. This was 1 over 5, therefore it's 0.2. Then plus the weight for stock INTC, okay, from the previous slide. This was actually 2 over 15, 4 over 15, okay, multiplied by 16.65%. This maintain that in fraction or in decimal, but this one you can put this in percentage. You don't have to convert this to decimal, because finally the answer will also be in percentage, not decimal. Okay, so this will be 16.65 here. Then plus the last element here will be the weight for stock BP, okay, which is 0.4, okay, multiplied by the expected return for stock BP, which is 18.24. Therefore, when you sum all these products, you get 15.41%. Okay, so that's the answer. This is the expected return for the portfolio. If these are the expected return for the individual stocks in the portfolio, okay, given the weights, portfolio weights for each of the stocks in the portfolio, this will be the expected return for the portfolio. Note again here that the expected return for the portfolio cannot be higher than the highest. Expected return for the individual stocks here. This is the highest, among the four, this is the highest. This cannot be higher than this. And this cannot be lower than the lowest. The lowest is this, 5.25%. Cannot be lower, It must be in between these two, actually, Okay, because it's weighted average, So that's one characteristic, of the portfolio expected return, So let's move on. Alright, this how you expand, This is the formula of the expected return for the portfolio given the expected return for the individual stock. J is the stock from 1 to M. Okay, in this case there are 4 stocks. So remember, I use the decimal here. I use the fraction rather than the decimal. I use the fraction here. This is the expected return for the portfolio. Hat. Return means expected return for the portfolio. P here stands for portfolio. Is equals to 2 over 15. This is the weight. Portfolio weight for stock C multiplied by 19.69% plus 1 over 5. This is the weight for the second stock multiplied by 5.25% and so on. This is 4 over 15 multiplied by 16.65, and finally 2 over 5 multiplied by 18.24%. So you add all these products, you get 15.41%. That's the expected return for the portfolio. Rounded to 2 decimal points. So you get the same answer. So this is the formula. So I hope you take note of the formula for the expected return for the portfolio. Alright, you can compute the portfolio return for each state. Okay, to compute the portfolio variance, now we look at variance and the standard deviation. For this, you have to compute the portfolio return. These are the possible return for each state. Okay, so here you need to compute this way. This is the formula given. I'll expand this formula a bit later. This is the possible return for the portfolio. This is portfolio return, but this is possible return. No hat. Possible return for the portfolio given the weight, the portfolio weight for stock 1 multiplied by the possible return for stock 1 plus the weight for stock 2 multiplied by the possible return for stock 2 given the state, given the state. Okay, so it will be difficult to just explain this. When we have an example, then this becomes clearer. The example is in the next slide. I'll show you the example a bit later. Now you compute the expected portfolio return using the same formula as for individual assets. So we compute the expected return here Okay, we used the expected return formula for portfolio in the previous slide. Yeah? That is when you already know the expected return of the individual assets. Okay, but here we assume that we don't know. But for portfolio variance, it's important to get the portfolio possible returns. Okay, now compute the portfolio variance in the same way. Yeah? So you can compute the portfolio expected return and the portfolio variance and standard deviation in the same way as you do for the individual assets, yeah? As you will see next. Now let's look at this example. Okay, consider the following information on returns and probabilities. Yeah? Invest here. You invest 50% of your money in asset A. There are two assets here. Yeah? If you invest 50% in asset A, then 50%, the remainder, yeah? 100 minus 50%, 50% must be invested in asset B. Alright? So, 50% in A and 50% in B. Yeah? So, here you are given the boom and bust. There are only two states, yeah? Not three. Yeah? Okay, only two, yeah? Two possible states. These are the probability of the two possibilities. Yeah? 40% chance that there will be a boom, 60% chance there will be a bust. Bust here means recession. Yeah? Boom means high positive economic growth. Okay, now if boom, then stock A, the return will be 30%. If bust, the stock A return will be negative 10%. Yeah? But if it is boom, stock B will be negative 5%. But if it is bust, positive 25%. Yeah? So that's the distribution of return for these two stocks. Now, how do you compute the portfolio possible returns? Yeah? This one. Yeah? Here it is not given. Yeah? Actually, it's derived from these two. Yeah? How is this derived? Okay, this is derived by using 50% in stock A, 30%, multiplied by 50% multiplied by negative 5%. Yeah, let's look at the next slide here. Yeah, this is how it's done. Yeah, so there is a 50% chance that there would be, sorry, not chance. Yeah, 50% of the investment will be in in stock A. Yeah, stock A. Stock A's return will be 30% if there is a boom. Yeah, this 1 stands for boom. Yeah, 2 stands for bust. Okay, 30% return for stock A, but negative 5% return for stock B if there is a boom. Yeah, so 50% will be invested in stock A, 50% will be invested in stock B. So this will be the weighted average return. Yeah, so that's the possible return for boom for the portfolio will be 12.5%. This is not expected return. Yeah? Note that this is not the expected return. This is the possible return for portfolio if there is a boom. Okay, this is the possible return for the portfolio if there is a bust. Yeah? So we use this formula. Yeah? This weight for both, yeah, will be 0.5 because there are only two stocks. If one stock has 50%, the other stock must also have 50%. When you add these two, it must be 1, yeah, or 100%. Alright, therefore here, it is 0.5 multiplied by negative 10% return. If there is a bust for stock A, the return will be negative. But for stock B, if there is a bust, the return will be 25%. Yeah? So the average of these two will be 7.5%. Yeah? That is what was given here. Yeah? Note this, yeah? 12.5% and 7.5%. It's actually derived from these two. 50% multiplied or 0.5 multiplied by 30% plus 0.5 multiplied by negative 5%, you get 12.5%. Okay. Now, what are the expected return and standard deviation for each asset? Yeah. So this we have already computed. Yeah. Therefore, I'm not going to go through the calculation in detail. Yeah. On paper, what I'm going to show you is how you can use Excel to do the same thing. Yeah. But this we have learned before, but this is what we are going to practice now. Yeah. What are the expected return and standard deviation for the portfolio? First, we look at individual assets, then we look at the portfolio, and we do this both, yeah, using Excel, right? Alright, and here you get the information. The same information is given in Excel, yeah. Now, boom here, boom, bust, yeah. Probability is 0.4, 0.6. The stock return is 30% if there is a boom, negative 10% if there is a bust. For stock B, it will be negative 5% if there is a boom and 25% if there is a bust. Yeah? So all these are given. Yeah? And this is also given, but actually these two you can calculate. Yeah? It's actually 50% multiplied, or 0.5 multiplied by 30% plus 0.5 multiplied by negative 5%, you get 12.5%. Yeah? Here 7.5% is 0.5 multiplied by negative 10% plus 0.5 multiplied by 25%, you get 7.5%. Yeah. Now how do you get the expected return? So we look at the answer for the first part here. Yeah? First part is here, or A, yeah, from the slide. Yeah. So expected return for stock A, how do you compute this? It is actually this multiplied by this plus this multiplied by this. You get 6%. Yeah, note this. Yeah, this is the answer. Yeah, you can use Excel to do it this way. Right, yes, 6%. Yeah, once you have got that, you can do the same for stock B. It is actually this 0.4 multiplied by negative 5% plus 0.6 multiplied by 25%. Therefore, you get 13%. Now, what is the variance? How do you compute the variance? Yeah. Now let's look through. Yeah, variance is always the possible return. You start with 30% minus 6%. Okay, that's the expected return. This minus this, then you square that. Okay, then you multiply with the probability 0.4. Yeah, that's the first element. Second element will be negative 10% minus 6%. You square that and you multiply with 0.6. You add the two, you get the variance. You know this is the formula. This 30% minus 6%, you square that, then you multiply with 0.4. That is the first element, because there are two elements here. One is for boom, one is for bust. Second element will be negative 10% minus 6%. You square that, then you multiply with 0.6. Okay, so you add the two elements, you get the variance. Yeah, the variance is given in decimal here, not in percentage square. Yeah, in decimal. Okay, so it's 0.03840. Now the standard deviation is simply the square root of this. Yeah, square root. You take this, you take the square root of 0.03840, you get this answer. Yeah, and now this is in percentage. 19.5959%, yeah, to 4 decimal points. So you can do the same for the expected return for stock B. Okay, same, yeah, same way, yeah. So let's go through this very quickly. 0.4 multiplied by negative 5 plus 0.6 multiplied by 25, you get 13%. That is the expected return for stock B. The standard deviation is this, negative 5 minus 13, you square that, then you multiply with 0.4. Then, that's the first element, you plus that with 25 minus 13, you square that, then you multiply with 0.6, you add the two elements, you get 0.021600. You take the standard deviation. How do you get the standard deviation? You take the square root of the variance, you get 14.6969. Note that here the standard deviation for stock A is higher than the standard deviation for stock B. Okay. Now, ignore the covariance. We don't have time to go through that. It's not so important now. Okay. So let's try and finish off for the portfolio. Yeah. The portfolio expected return will be the same method as we compute for the stocks. 0.6 multiplied by 12.5 plus 0.6 multiplied by 7.5. You get 9.5%. That's the expected return for the portfolio. Then what is the standard deviation? Standard deviation, you take 12.5% minus 9.5%. You square that. You multiply with 0.4. Then plus 7.5% minus 9.5%. You square that. Then you multiply with 0.6. So this is your standard variance. Yeah, your variance is this 0.000600. Yeah, it's very small. Yeah, If you take the square root of this, then you get the standard deviation. Yeah? So that's how you compute this. But before we end, note